They're not always on our minds, but our lives are powered by batteries. For most of us, not a day will go by that we're not using a battery, whether it's in our cars, our phones, the remote to the television. If you've ever tried to find an extension cord to plug in a vacuum or a hedge trimmer, you might realize the importance of portability. And this is what makes batteries so important. Imagine using your phone or MP3 player while being plugged into the wall. The convenience of batteries has led to the invention of more new technologies, appliances and equipment that operate best with flexibility of range. There are now commercially available automobiles fully powered by batteries, eliminating the need for a transmission and emissions. There are fully functional lawnmowers with sufficient power to cut through thick grass, and there are large-scale batteries that are being built to harness the power generated by renewable energy sources, such as solar and wind. Batteries have been around for over 200 years. The first batteries used chemical solutions and were inconsistent and dangerous. They contained wet cells with liquid electrolytes, which were prone to spillage. Italian physicist Count Alessandro Volta was the first to create a battery in 1799 from metal plates and brine-soaked cardboard or paper. Since then, scientists have built upon Volta's original design to create batteries made from a variety of materials that come in many sizes. A battery is a device containing an electric cell or series of electric cells storing energy that can be converted into electrical power, usually in the form of direct current. This is known as an electrochemical reaction. Batteries store chemical energy and convert it into electrical energy. A typical battery, such as a car battery, is composed of galvanic cells. Each cell contains two separate metal electrodes immersed in an electrolyte containing both positive and negative ions. Batteries are equipped with two terminals. The positive terminal is marked with a plus sign, while the other is marked as negative. In most small consumer batteries, such as the AA, C, or D cell, the terminals are located at opposite ends. On a car battery or a 9-volt, however, the terminals are next to each other on the top of the battery. These terminals are then connected to a load, such as a remote control, a motor, or a radio. Batteries usually have a metal or plastic case. Within the case is a cathode, which connects to the positive terminal, and an anode, which connects to the negative terminal. These components are known as electrodes and are where the chemical reactions occur to create power. Between the cathode and anode is a separator, which prevents the electrodes from touching while allowing electrically charged ions to migrate between the two. The conductive medium that allows the electric charge to flow between the cathode and anode is the electrolyte. Finally, the collector sends the charge to the terminals on the outside of the battery, which powers the load. In the United States, most household batteries, such as the AA, C, or D cell, are alkaline batteries. This type is dependent upon the reaction between zinc and manganese dioxide, and it gets its name because it has an alkaline electrolyte made of potassium hydroxide. The mobile device boom of the past several decades has increased the demand for longer-lasting rechargeable batteries. Lithium is the lightest of all metals, has the greatest electrochemical potential, and provides the largest energy density for its weight. Pure lithium is highly reactive. It reacts vigorously with water to form lithium hydroxide and hydrogen gas. Lithium-ion batteries are now one of the most popular types of rechargeable batteries for portable electronics due to their high energy density, no memory effect, and slow loss of charge when not in use. Handheld electronics mostly use lithium-ion batteries based on lithium cobalt oxide. The battery works because lithium ions move from the negative electrode to the positive electrode during discharge and back when charging. A lithium-ion battery is nearly the same as the alkaline battery in design, but the chemicals are different.
Rechargeable battery cells are manufactured in cylindrical or prismatic cells, as this animation illustrates. First, copper is rolled into a foil that serves as the current collector on the anode side. Aluminum is used on the cathode side. Next, the electrode is deposited onto the current collector foil. The anode is typically made of graphite and the cathode of lithium containing oxides or phosphates. The electrode coating goes through a drying step in which unnecessary solvents are removed and the slurry-based coating is solidified. After drying, the two electrodes come together in a sandwich structure with two separators, shown in green, positioned in between. This flexible layer structure then goes through a winding process and forms what is called a jelly roll. For prismatic cells, these structures are cut and layered, flatly rolled, or Z-folded. Next, the jelly roll is packaged into a cylindrical container that resembles an oversized AA battery. Here you can see the internal structure consisting of the two current collectors with electrode and the two separators for avoiding a short circuit. Before sealing and crimping the container, the battery is filled with liquid electrolyte. It is critical that the electrolyte wets the separator and fills all pores, leaving no or minimal voids in the separator foam. 8 to 12 cells are packaged in a module. Then 8 to 12 modules are packaged with a battery management and cooling system. Such a battery pack can then be used in plug-in hybrid and all-electric vehicles. The same or very similar battery packs can be used for stationary storage to enable intermittent renewable energy sources such as wind and solar.
The volt, or voltage, is the unit of measurement for the work done by a machine powered by an electrical source, similar to how horsepower is a unit of measurement for the strength of a combustion engine. A battery's capacity is measured in amp hours, which is similar to the amount of gasoline in a car's tank. Higher amp hours result in longer battery run times. While many standard battery-powered lawnmowers utilize a 40-volt battery, Ego is a company that has revolutionized the world of outdoor power equipment with the industry's first 56-volt battery. This increase in power makes yard work easier with improved performance and durability. Now, to help put things into perspective, smartphones require 5 volts. A vacuum cleaner is often 15 volts. Circular saws work at 18 volts. Electric drills need 20 volts. Most battery-powered outdoor maintenance equipment, 40 volts. The Ego Power Plus lawnmower is 56 volts. How were Ego engineers able to design this 56-volt battery system to work efficiently? Well, more volts means more power, which results in more heat. Heat is bad for batteries. The Ego Power Plus lithium-ion battery features breakthrough technology, a unique arc shape which allows it to dissipate heat more effectively. Ego's batteries also use a phase change technology to draw and dissipate heat from individual battery cells. These two features make it possible for Ego to provide the highest voltage lithium-ion battery platform that can operate under hot conditions. Careers in the fields relating to batteries can be exciting and rewarding. Just to name a few, they are engineer, specifically electrical engineer, materials scientist, chemist, physicist, and nanotechnology researcher. While we may often take batteries for granted, they are all around us, powering our phones, computers, flashlights, cars, and many other portable devices. Batteries are a modern convenience that we've come to depend on more and more in recent years. In fields such as health and renewable energy storage, we'll see exciting new advances. With additional research and innovations, batteries will become smaller, more dependable, and will last longer in the future. They are a modern convenience that will help improve our quality of life for years to come.